Hello, and welcome everyone to our session today. We'll be talking about running and managing Linux with Windows Server, System Center, and Azure Pack. My name is Christopher Bash, and my colleague.
I'm Anurag Gupta.
We're both program managers in a team at Microsoft called the Open Source Technology Center, or OSTC. And it's actually a product development team. We're part of the Windows Server organization, and we do development work supporting quite a breadth of Linux and Unix capabilities in System Center, Windows Server, and then some of the Azure IaaS support. Has everyone seen this slide? A few times, hopefully. So we've actually been down in the expo hall giving out some buttons and stickers that have Microsoft Loves Linux. We love this slide. We've actually been doing Linux management for quite some time, going back 2009 with Ops Manager, Unix and Linux monitoring. Started work on Hyper-V integrations not long after that. Linux was supported in Azure on day one. But still, it's hard to imagine this slide being shown 3 years ago, let alone a CEO of Microsoft standing in front of a slide like this. So what's changed? What we really want to convey with this slide today is that there has been this sea change or a critical mass at Microsoft. We're seeing from top down across the organization some real thought around, rather than building a feature for Windows first and how do we get that on Linux later, but actually thinking about Linux as a platform target from day one of engineering. You've seen some evidence of this recently with .NET Core going open source and being ported to Linux, with Visual Studio Code announced last week for Linux and Mac. So, there's just, and then of course Azure is just this constant stream of new features coming out for both Linux and Windows. Definitely a huge change from Microsoft, and we're loving it. This is a great time to be working on Linux features at Microsoft. A lot less lonely than it was 5 years ago. So why? I'd like to characterize this change as the triumph of pragmatism. This isn't a philosophical change. This is just a recognition of the reality. We've been hearing from you folks, from our customers, that for years, that your data centers are heterogeneous, that you're running Windows, you're running Linux, many of you, I'm sure, are running Unix. At the end of the day, you just need it all to run. You need to be able to manage it. You need to be able to you want a centralized infrastructure, a common set of tools. You don't want a management stack for one operating system versus another management stack for another operating system. We've internalized that message. We get it. That's what's driving this change. It's just good business for us. And at this point, I'll let Anurag.
Thanks, Chris. So at Ignite this week, you're going to see a lot of sessions about the public cloud, some of the great management we're bringing with OMS. But today's session, we're going to focus on running Unix and Linux in your data center today. We're going to talk about your traditional environments that might have Windows, Linux, or Unix, bringing that to the virtualized environments, and then Microsoft's public cloud with Windows and Linux. And so this is going to be a 200-level session. And we're really going to focus on what you can do today with System Center and Hyper-V 2012 R2. So right after this session, many of you will go out and start managing Linux today. I'll put a bet on it. So a brief agenda. So first, we're going to go an introduction of what products we offer, what is the level of Microsoft and Linux, what operating systems are supported. Talk about running and deploying Linux. What Linux integration services are, virtual machine manager, Windows Azure Pack, and then step into managing and monitoring Linux with System Center Configuration Manager, System Center Operations Manager, and then lastly, automation with desired state configuration, or DSC. So supported operating systems. If you came by our booth, you might have seen this slide up. A great slide showing we're not just going after one Linux version and saying, yeah, Microsoft supports Linux running there. No, we've actually gone after most of the enterprise Linuxes. So you've got Red Hat, SLES, CentOS, Ubuntu, Debian, and Oracle Linux. And we've also done the work for managing and monitoring the proprietary Unixes, so IBM AIX, HP HPUX, and Oracle Solaris. And Chris had mentioned, 2009 Operations Manager support started. We've been doing this for a while. 2010 Hyper-V came out, in 2013 Day 1 IaaS Linux VMs. And we're not really going after the hobbyist VM, so your Fedora, Mint, or even Hannah Montana Linux. That's not going to be anytime represented in this matrix soon. And we understand there's some more boxes to fill here. Stay tuned. So running and deploying Linux. This is going to start off with Hyper-V and integration services. What are they? So Hyper-V is going to present synthetic devices to the guest OS, its disk drive or network adapter. And then your guest OS is going to say, hey, I need some drivers for these devices. And that's where integration services are going to come in. These are going to be the guest OS drivers for Hyper-V. These are drivers written for that specific guest OS. So Red Hat or SLES might need something different for that synthetic device. We're making sure that we're writing for that platform. So your Windows integration services are different than your Linux integration services, which are different than your FreeBSD integration services. And then we've also done the work to make sure there's specific drivers for user space daemons that are going to be interacting with these drivers. And then secondly, with Linux integration services, what are the versions supported? How am I going to go get it? So in the matrix you saw, we're going after all the enterprise Linuxes there. There's a breakdown of the versions and LIS availability. So the first way you're going to go get these packages, you're going to go online and download it. And the second is you already have it. We've done the work to commit to the Linux kernel. Those changes have been picked up upstream. And we've worked with distribution vendors to get those drivers integrated with your favorite enterprise Linux. And then, of course, your support strategy. How do I get support for my Linux running on Hyper-V? We've worked with the vendors to make sure that you can contact them directly. And if you have Hyper-V issues, you can contact the Linux vendor or us. And lastly, if you guys are not aware, LIS 4.0 came out earlier this week. Publicly announced, and that's going to be a bunch of performance upgrades and XIO improvements. So I highly recommend you guys go out and download that as well. And with that, I will hand it off to Chris, who will talk about deploying Linux.
Thanks, Anurag. So when we talk about like a Microsoft private cloud story, we're really starting with System Center Virtual Machine Manager. VMM has kind of two key roles in a private cloud. First, it's your fabric manager. You define your networking, your storage. You can manage your hosts, your hypervisors. Just recently, VMM added the ability to do some management of your AWS and Azure VM assets. So that's a cool new feature. VMM also allows you to build out some templates, so VM templates, service templates, which are multi-tiered VM template implementations, and then deploy those, manage those VMs, start, stop, snapshot, that kind of thing. Azure Pack is and again, as a reminder, we're focused on technologies that are generally available today. When we talk about Azure Pack, we're talking about Azure Pack 2, which is available now, not the new Azure Stack, which was announced earlier this week. So Azure Pack is really around bringing that kind of multi-tenant Azure portal experience into your data center, primarily looking at using VMM as the underlying fabric for that. That's actually integrated through a component called SPF, which does that fabric to tenant integration. And it really lets you, have a nice self-service portal. It's very familiar because it shares some UI with the Azure portal. So VMM, we added Linux specialization support, VM templates for Linux, back in the 2012 SP1 release. So for a Linux VM template, it really consists of three parts. First, we have a VHD or VHDX image with the Linux operating system. So we would start with, we go build out our image, probably by mounting a DVD, a virtual, an ISO of a DVD of the Linux OS, build out the Linux OS, get it configured how we, generally how we want our template to look. Make sure that the LIS, the integration services are there. For most modern Linux versions, that's going to be built in. And then we would install the VMM agent. The VMM agent is a very trivial and ephemeral agent that implements kind of an analogous behavior to sysprep on Windows. It's going to do some depersonalization, like fleshing out your bash history. So when you deploy a new VM, you can't see what commands were run before that from that template. And then the VMM agent is always also going to do the personalization. It's going to set the networking and the host name and things like that. We take that VHD and then we combine it with a hardware profile, which just defines the virtual hardware, memory, CPU, things like that. Just as Linux and Windows can run on the same physical hardware, Linux and Windows use the same hardware profile in VMM. In fact, there's actually no code difference there in the hardware profile. And then the last part of our VM template is the OS profile, which is Linux specific. We certainly didn't want to try to shoehorn Windows operating system settings onto Linux and do some kind of weird abstraction there. So that's all new, all specific code. At that point, VMM knows you're working with Linux. You're presented with options for like your DNS domain name, your root password and SSH key. And we'll definitely look at these run once command lines in a demo. Those are your primary extensibility option with VMM for Linux. It's a set of commands, arbitrary commands, and you can order them. You can actually set individual timeouts on them that are run after the VM has been specialized. See, at that point, your host name is set, your network is up, and you can use those to install additional software, to bootstrap a configuration agent, or to do additional customization that wasn't part of the OS profile. Walking through how this actually works, it's very similar to the way a Windows VM is specialized with VMM. We start with a VMM server, has a library with our VHDs, has a database with our templates defined. When you go to deploy the VM, VMM will generate a specialization doc. This is, you can think, if you're familiar with Windows, you can think of this as your unattend.xml. It's actually much less complex than unattend.xml. So it's pretty straightforward. That specialization doc and the latest version of the VMM agent for Linux known to the server are put on an ISO. It's all shipped out to the hypervisor host. The host agent creates the VM from the specification, mounts the ISO in the virtual DVD drive, and boots that VM. When you installed the VMM agent, when you were preparing that VHD, it actually registered itself as a daemon. So when that VM boots up, the VMM agent is going to fire up. It'll check the DVD drive, try to find the specialization document. If it finds that, it then compares the agent version on the ISO to the agent version it has installed. And if the agent version on the ISO is newer, it'll upgrade itself. That's actually so we can do bug fixes, add features without you having to go and crack open all your VHDs and upgrade the agent every time we issue an update rollup for VMM. At that point, it does the specialization. It sets the host name. It sets the network configuration. Runs your run once commands. Sets your credentials. And then it shuts down to indicate to the VMM server that it's successful. So pretty straightforward, but it's hugely useful. Azure Pack we'll look at in a demo. For the most part, Azure Pack just works for Linux. There's really not a lot that had to be done there to make Azure Pack work with Linux. It has from its first offering. With Azure Pack, you can of course expose your Linux VM templates from VMM into Azure Pack, share those out to subscriptions, and just use those as standalone VM templates. You can also author VM roles. VM roles give you a little bit more ability to parameterize your configuration. And then, again, with the VM role, you can use the run once commands as a means of doing extended configuration. So let's have a look at how this actually plays out. So we're looking at a VMM server here. I have a couple of VM templates, one for CentOS and one for Ubuntu. And of course, the hardware here, I've defined my processors and memory, and the disk drive where it's referencing the VHD I created that has LIS built in and the VMM agent installed. Of course, I can set the networking. And then for the OS configuration, all the name pattern behavior of VMM around incrementing, incrementing numbers in the names and using star for a randomly generated name. That's all works for Linux. We can set our root credentials and time zone. We can set public SSH keys for the root user. And then these run once commands I talked about earlier, I'm actually bootstrapping the DSC for Linux agent, which we'll demo later in this session. If you're using Chef or Puppet, this is a great place to inject that. And the way I'm injecting that is actually by just doing a wget and pulling it down from an internal web server and then doing an installation. So that's a great way to kind of bootstrap your next order of configuration for the VM. I'll tab over to Azure Pack here. So those two VM templates simply show up as because I've shared those out with subscription, as my gallery for a standalone VM. So I could go through and deploy my CentOS VM, provide it a name, a root password, paste in my SSH key for my root user, and kick that out. I've also gone ahead and created some VM roles, largely abstracting that same template. But it gives me a little more flexibility. So I'll deploy a VM role here. I can pick the size, and this would control the hardware that's allocated to it. Let's call it our Ignite VM. And in this case, I'm actually, because I want to, instead of using root, I want a lower user, a non-privileged user with sudo. I've set that up in the UI in the VM role template, and I have some run once commands that make that happen. And I can kick that out. Of course, on the VM roles, we can go in and look at a previously deployed one, drill into our instances. We could scale that out. Of course, this is all accessible through programmatic APIs as well. So if I wanted to scale out a VM role, I could just save that configuration. So pretty cool private cloud stuff, totally viable for Linux, available now. And we'll switch back to Anurag here with moving into management.
Thanks. And so just a quick poll of the room. How many of you guys are Windows admins that have now been tasked with managing Linux? Cool. Okay, a lot of the room. All right, good to see. Glad you're here. We're going to talk about the solutions we have. So first up, we have System Center components. We have Configuration Manager and System Center Operations Manager. With Configuration Manager, you're going to have three scenarios. You're going to first have hardware inventory. That's going to give you a component layout of what your Linux servers have, what installed applications you have, and you can go ahead and create collections based off that. Secondly, you have software distribution, so you can deploy packages to your Linux servers. You can deploy packages to your Unix servers, arbitrary maintenance scripts. Maybe you have a Python script that needs to go run. And lastly, reporting. So you can report on that hardware inventory. You can report on the success of a software distribution, and that will extend across your Windows and Linux servers. And finally, you have endpoint protection. That's available as well. And then Operations Manager, that's going to be your day-to-day monitoring. We have a Linux agent that goes out onto your Linux server or Unix server, and we'll get OS health and performance, and that's going to be specific to Linux. So, inodes and swap space give you alerting on that. And then on the next level of what's running on your Linux machines, we can monitor, the log files that are in there, specific shell commands, and also, Java application servers. as well as line of business apps and database and web servers. And also at the end, you have audit security events. So say, Chris over here is suiting as root a lot of times more than he should. I can go ahead and discipline him as necessary. So stepping into Configuration Manager, an architecture overview. So in the green, we have our existing Config Manager 2012 R2 setup. This is whatever you have today, what took you a couple months to set up on Windows, it's going to be the same. You're not going to be adding new management points, new distribution points. It's what's there works. And in the blue, you have the Linux or Unix server. And the first thing we have is the client. And it's the equivalent of ccmexec.exe on Windows. So we've actually named it ccmexec.bin on the Linux side, and that's what's going to be doing the communication with your management points and distribution points. And then secondly, you have the OMI server. That's a SIM server, stands for Open Management Infrastructure. And this was jointly developed by Microsoft and the Open Group. And so you can go out and look at the source code from the Open Group today. They just updated to 1.08. So great stuff there. And it's the equivalent of WMI service on Windows. So you have a provider-based model. It's your WMI providers on Windows. You have OMI providers on Linux and Unix. And if you have custom requirements that you need to grab specific OS resources, you can write custom OMI providers and plug that right in. Oh, sorry, I see you taking a picture. Do you want to? So hardware inventory. Hardware inventory. You can look at a single computer, Resource Explorer, look at what's installed, what components are there, what the installed applications are like. So on the Windows side, we're looking at the MSI database. On the Linux side, we're going to look at your RPM and depackaged databases full of all those installed applications, and the proprietary Unix side as well. And then you can create collections based off this hardware inventory. So say, you have OpenSSL with Heartbleed. You can create a collection of all the computers that have that specific package, or hardware inventory of all your Red Hat machines, hardware inventory of or collection of all your Red Hat machines, or CentOS machines. And then finally, you can run reports that are going to aggregate across Windows, Linux, and Unix. So, if you want interested in what your site looks like, you can have a report that looks at all the operating systems and all the versions that are contained for that one point. And then software deployment, this is going to let you deploy packages, whether those packages are going to be updates to installed applications or OS updates. You can go ahead and distribute those to whatever collections required. So say I had that OpenSSL Heartbleed bug, I could deploy a package for an update to OpenSSL. And then finally, we'll let you run arbitrary maintenance scripts. So say you have a specific shell command that you've been running for the past 5 years. We're not saying to throw that away. Why don't you bring in a configuration manager, use our rich scheduling, use our maintenance mode windows, have that run and get reporting back on it. That's one of the things our customers love is running these arbitrary maintenance scripts and then using that rich reporting that configuration manager already has. And so going through a quick implementation with Windows, right, we're going to specify a package, an MSI, something else, plus a program. Or we'll send an advertisement to the management point, and the Windows client will say, hey, I got a policy. Let me go ahead and download that package. That'll be through SMB or HTTP. And then we have that maintenance window, so we'll install during that. And then we'll send a status message back to the management point. And so let me introduce Linux and Unix here. So same thing, specify a package, but this time it'll be an RPM or a PKG for Solaris, and then a program command line, so your shell command, your bash script that's going to install this. You'll send out a Linux and Unix advertisement to the same management point, and this time your Unix and Linux server is going to go ahead and say, hey, I need that policy, and I'm going to download that package from that same distribution point, no need to make another one. And then I'm going to install during a maintenance window that you set, and I'll send a status message back up to the maintenance management point. And so the Linux and Unix editions are going to dovetail with existing console and UI. You don't have a different window. You don't have a different management point, distribution point, the same hardware infrastructure, and same paradigm. So if you're used to using SSCM today, it's very easy to plug in Linux and Unix into that system. And so I'm going to go through a quick demo here. So let's go through that scenario of OpenSSL has come down upon my data center, and I have to go ahead and patch it as the IT admin. So here we have all of the devices or servers that are part of my system, and you can see my Linux ones are just going to plug right into Windows. Zoom in there. And you can even see that, hey, Chris deployed his service, and that showed up here. I can go ahead and approve it or deny it, depending on what I want to do. And let's go ahead and take a look at some of the hardware resources. So I can go ahead and go to Resource Explorer, look at some hardware. So we got, computer system. Look at what that looks like. Network adapter, disk drives. So what you're used to on Windows, we're using the same system tables as we did for Linux and Unix. And then I can even start drilling into some of the installed applications. So I got a nice list here. So let me filter with OpenSSL. Cool. So I could drill down into what's exactly installed on that one system, and then I can go ahead and make collections based off that. So here I have CentOS servers and then CentOS 7 with OpenSSL 1, and so I can look at which computers are part of that, deploy updates to that, deploy updates to CentOS 7. And then let me go over here and look at a deployment that I've run previously. So there's reporting. I can look at deployments. And so this deployment was running a Yum update. So we support those hardware maintenance scripts. So using the native package manager like Yum, apt-get, and Zypper, all is supported. And we can see here that, hey, my Yum update for OpenSSL was successful in both those computers in that collection. And so let me say, hey, now I need to go run a report so I can feed it up the chain. So head up to reports. So I could say, hey, what versions are installed? I can run that report. And loading. There we go. And I can say, hey, print it out, hand it to my boss, tell him, hey, we're good to go. OpenSSL Heartbleed, no problem in this data center because we got config manager. Okay, switch back to this. And so I will pass it off to Chris, who will talk about operations manager.
Who today is using Ops Manager for Unix and Linux? And who is interested but not currently? Cool. For those of you who are new to Ops Manager or are new to using Unix and Linux Ops Manager, I like to get this out of the way first because there are some differences in the actual implementation, the architecture underneath. Once you get above that architecture into the console, into the management packs, a lot of those differences disappear and you have a much more consistent experience. But at the actual agent level, there are some differences. So on this chart on the left side, we have a representation of the management server, our management servers, and you have the SDK service, the config service, the health service. And then on the right side, you have your Windows computer with a managed Windows computer with its own health service. When that agent fires up and it's all improved in the environment, it will pull down configuration in the form of management packs. It will load those workloads, those workflows locally, those rules and monitors it's going to run, and then push back events and data and state to the management server. So this is a little different for Unix and Linux. The agent for Unix and Linux is a much lighter weight agent, whereas we have a full or fat agent on the Windows computer. We have a very lightweight agent on the Unix or Linux computer. In fact, it's very similar to just what you have in Windows in WMI. It is a SIM server. OMI, same OMI that Anurag talked about with Config Manager, and then a set of providers that enumerate data around like the running processes and processor performance and memory statistics. There are two kind of key protocols that are used here, talking from the management server to the Unix and Linux computer. Firstly, for agent maintenance only, for when we need to install the agent, uninstall the agent, upgrade the agent, using the PowerShell commandlets or Discovery Wizard or Upgrade Wizard that are part of Operations Manager. That's done over SSH. It's kind of obvious why we need that, because we're not sure that we can't talk to our agent if we're installing it or uninstalling it or upgrading it. For those SSH connections, we support SSH key authentication, sudo elevation, su elevation. Pretty much every one of those actions done over SSH is a privileged action. We're talking about installing and uninstalling packages. All monitoring, everything other than administering the agent itself, is done over the WSMAN protocol, or Web Service Management Protocol. This is a standard SOAP-based web service protocol for doing management with SIM servers. So the key difference here is that for Unix and Linux, the management server, Windows server, is the health service for the Unix and Linux computer. It does a lot more of that processing in a centralized fashion. You have a lighter weight agent on the Unix Linux box, and that may come into play when if you're troubleshooting Discovery or Workflows, things like that. Once we get beyond that and into the management packs, there's a lot of similarity between the management packs for Unix and Linux and Windows. We've been iterating on kind of the same base operating system management packs for Unix and Linux for about 6 years now. So we feel pretty good about the kind of coverage we have out of the box for your Unix and Linux operating system. CPU performance metrics, memory statistics, disk statistics and availability, looking for things like free space and inodes, as well as disk performance, network statistics we collect. We have some out-of-the-box monitors for kind of essential daemons on your Unix and Linux computers. And then we'll look at how you can customize process monitoring. And likewise with log files, we look for some key kind of security-related events in the system logs, and then it's fairly easy to customize that. So pretty good coverage of that kind of core operating system. Unfortunately, that's usually not enough for monitoring. We might want to know about higher level services than the operating system itself, unless we're just running operating systems in our data center. Key area of extensibility with Ops Manager for Unix and Linux is through these templates. If you've been working with Ops Manager and you've done some management pack authoring, you can do a lot with management pack authoring. The point of these templates is to make common, easy customizations very accessible, very rapid to implement. You can absolutely go a lot deeper once you start working with management packs and Visual Studio and stuff like that. And the templates themselves, log file. So give us the path to a log file, give us a regular expression pattern. We'll scan that periodically and then alert if we match lines in that, if that regular expression matches lines. Process monitoring. Give us the name of a process, tell us how many minimum, maximum should be running, and then we'll alert if you exceed those boundaries. Back in 2007 R2, before we added this feature, we used to have a lot of customers who said, hey, what do I do about, I've got 10 Java processes and only one maps to this specific application. I want different alerts. So we did add the ability to filter that process monitoring by the arguments to the process. So you can distinguish when you have multiple processes of the same name that actually represent different applications. So those two, process monitoring, log file monitoring, that gives you a pretty good minimum viable monitoring for an application. We hear a lot from customers who have invested a lot of their operational intellectual property into shell scripts. Over the years, monitoring tools may have come and gone. Those scripts have stayed. Those are super easy to plug into Ops Manager with these shell command templates. Allow you to build a monitor or a performance collection rule, an alerting rule by running any arbitrary command, which could be a script on the file system, a shell one-liner. With the 2012 release, we also made our first foray into actual application management packs for Unix and Linux with JE App Server Management Packs. These support Tomcat and JBoss and WebSphere and WebLogic. We'll find your JE app servers on Windows or Unix or Linux computers. Then we have an open source application, a servlet called BeanSpy that is effectively an interface to JMX, the MBean store. And that corresponds to a template implementation operations manager. It allows you very easily to get properties and methods in your JMX implementation into Ops Manager rules and monitors. So out of the box, we're going to give you some key performance metrics around memory heaps and garbage collection. But then if you're instrumenting your Java applications in JMX, it's very easy to bring that into Ops Manager monitoring. So I should probably pause here for a second and point out that in a session tomorrow morning, we're going to be talking about new features for System Center 2016, and where we will introduce that we're really building on this management packs monitoring for open source applications theme. So be sure to, if you can, check that out. If not, catch the video after the fact. We'll be talking more about what we're doing with management packs for the application space. If you walk the expo halls, you might have seen some of our partners, particularly around commercial applications like Oracle, DB2. We have a really good partner ecosystem. There are 3 partners down on the floor of the expo hall that have really good Oracle database management packs. That's one that's a little complex to try to build yourself. We definitely, for something like that, would steer you towards our partners. And I think all of these are actually at the expo hall this week. All right, let's have a look here at Operations Manager. All right, so we are looking at a dashboard of some Unix and Linux computers. And I can jump over to a state view of Unix and Linux computers. These happen to all be the Linux computers running in my lab environment. Again, if you've not used Unix and Linux and Ops Manager, at this point in the console, it's going to look very much like for Windows. I can open up the Health Explorer, and let me drill in and see what we're looking at here for monitoring. So we've got some monitoring on our file systems. We'll do some monitoring for the agent itself, some heartbeat monitoring. You can, if you want, you can use that as kind of an up-down monitor as well. It'll alert you if the agent is not responsive, which would also apply if the machine were not responsive. And do some performance monitoring for swap and processor metrics. And we can, of course, look at processes, like this one's looking at SSHD. We've done a lot over the years to actually really try to build out our knowledge articles that display in here, try to give some good explanations of how the data, how those metrics are calculated and what could potentially cause an issue there. Additionally, we have a couple tasks that we ship out of the box. So if you're investigating a performance issue and maybe you want to hop over and see what top 10 CPU consumers now are running on the box. And this is actually running like a SIM method invocation out to the box to get a real-time picture of process consumption of CPU. And of course, because it's operations manager, we take a model view of the world. And so we can jump into the diagram view and see all the assets that are discovered on this box. So here's our operating system, our network adapter, our file system, and we'll collect some data about what that is. For each of the operating systems, we ship like 10 or 12 reports. We kind of overhauled these back in the 2012 release to be a little more targeted to Linux and Unix. So we can jump into like the performance history report for a machine. Again, this is all SQL reporting, like much of like the rest of System Center. Any custom rules you add for performance collection, if you're using a shell command, those all go into the data warehouse. And there are some generic reports right in the console, and you can go report on those. So if you do your own custom management packs or your own shell command templates, you can build reports on those, schedule them, etc. I'll run this. It should give us a quick overview here. All right, looks like it wrapped up. And of course, we could it's SSRS, so we could schedule this, we could subscribe to it, we could save it to our workspace. And in a similar vein, we have a number of performance views in the console. So if I wanted to jump in and just look for a performance metric on swap space, and jump into this performance view, search for it, pick the machine, and set my time range. Maybe I want to look just for today. And then we ship a number of, in those core management packs, a number of views for kind of these dashboard views. So if you want to load up these charts and really focus on a particular performance area for your machines. Of course, all the dashboarding investments that have gone into Ops Manager over the years, the past few years, are viable for Linux and Unix as well. But let's move over to some customization. So I talked about those three templates we have in Ops Manager 2012 R2. We can start by looking at the process monitoring template. And let's say I've got a Linux DNS server running bind, and I want to know that named D is always up and available. I can create a template. Let's call it like Linux DNS daemon. Before the conference, I created a management pack and a group. Now with this process template, I could just go in. I actually know that bind's daemon is named D, but I could, maybe I don't, not quite sure. Can never really remember which distros name Apache HTTPD and which name it Apache 2. So I can browse out to the machine and actually find my daemon, select it. And this is where I would, if I had multiple processes with the same name, I would provide my regular expression to filter that. In this case, I want to actually, let's target a group that I created. So any Linux servers in that group will get this process monitoring for the named D daemon. And again, minimum, maximum number of processes. You can pretty much get to whatever you need on that threshold. All right. Log file template is really quite similar. I'll just show what this looks like. So again, we would just go into the template wizard, provide a name, put in our management pack. Of course, if we can use those management packs to move things out of our dev environment into our test environment, into our production environment. I can pick a computer or group. Provide a path, and then our regular expression. So pretty straightforward, but ultimately a quite essential bit of customization. So we did our process monitoring template to monitor our DNS server. It's a pretty good start for monitoring that our DNS server is working if the process is actually running. Doesn't quite give us everything we would need to know. Maybe I'm concerned that my DNS server can't resolve public addresses. With a shell command, like say, let's use dig against the local host to resolve a public address, and then use grep and wc-l and get a numeric status value based on whether my dig command worked or not. Ultimately, this is a one-line command that will tell me if my local DNS server can actually resolve a public address. So if I wanted to build a monitor on that, I would simply come into create a unit monitor, pick shell command two-state monitor. I'll keep going with this management pack. Let's see, test DNS found. Give the monitor a name. Select my target. Say, check this every 5 minutes. I simply paste my command in there. This command doesn't require any privileges. I could select my privilege account. That would allow me to use sudo authorization to do something that required actual privileges, like if I wanted to run like a cluster monitoring command like clustat, that requires privileges, and it had to authorize that with sudo. So then we build our actual expressions. This should be very familiar if you've done some templates in the operations manager. So we'll say we are, I think it was unhealthy if our output does not equal 1, and healthy if our standard out equals 1. Okay. We can set a severity, and then specify our alert text. And of course, we can drop in like the target variable. So let's drop in our host name of the Unix computer, and then let's put in the output from our command. So if we've got a one-line command, we have a script we can call and get some output. Really easy to bring that into monitoring. There's again, an alert collection rule, a performance collection rule that allow you to, that use the same UI, the same kind of capabilities. All right, let's jump back to the slide deck here. So anyone worked with DSC before? PowerShell desired state configuration. This is actually a new capability for Linux. It was new for Windows in 2012 R2. We just released this for Linux earlier this week. It's not actually a system center technology. It's as a feature of PowerShell. But I think you'll see how well it integrates with this Linux management environment. For those of you unfamiliar with DSC, and this is just generally PowerShell desired state configuration, it is a declarative configuration platform. You can define a configuration, set this file with these contents at this location, make sure it exists, and then leave it up to DSC to make that happen. Doesn't matter what the state was before, DSC is going to get it into that state. This can be used to protect against configuration drift. We can have a DSC agent reapplying its configuration. So if you set an ACL on a file with DSC, someone changed that, DSC will set it back. And DSC is a little unique in the space. It's all standards-based. The actual configuration documents are MOF documents. Communication protocols are, again, WSMAN. So with DSC for Linux, again, this is using OMI, similar to our CM and Ops Manager agents for Unix and Linux. Same kind of Linux support matrix that we've seen. It's open sourced on GitHub. What we've done for DSC for Linux is we've ported the agent component, the local configuration manager, which was actually written in C. It was designed to run on both Windows and Linux, but we ported that over to Linux, made sure that it worked, and that's actually an OMI provider. And then it has a set of resource providers. These do things like manage archive files and the lines within a file, which is actually really critical in Linux. Packages, so we can say, define in the configuration that these packages should be present, these should not be present, users and groups and scripts and services. And we support things like poll servers for centralized distribution of configuration. If you've not seen the DSC configuration before, it's actually it's pretty readable. So this is an example configuration that would, if applied to a Linux computer, would make sure that the HTTPD and mod SSL package were installed and that the Apache service was running and enabled on boot. And this would be in PowerShell. I would actually run that. It would generate a MOF document, just a standard document describing the configuration. That MOF could be pushed out over a SIM session to the Linux computer, or it could be distributed on my central pull server that I've registered all my Linux and Windows computers to go pull down configurations from. So let's look at this in our demo environment. And there are a number of kind of key scenarios that DSC is useful for. In fact, in our session tomorrow morning, I'll kind of look at, do a demonstration of using DSC as a continuous deployment scenario, so dropping a web app on a share and distributing that out to your web servers. In this case, we'll be looking at it more as like a VM provisioning. So I mentioned earlier with our VM templates that we were bootstrapping the DSC agent by installing it with those run once commands. So when I actually deployed that out through the Azure Pack, I had the Azure Pack configured to kick off an SMA runbook whenever a VM is deployed. That SMA runbook grabs data out of the template deployment, like the operating system, and passes it off to another runbook that actually is just a DSC script. So if you recall our slide earlier that had some example script, you'll see some similar syntax here. And for those of you who've worked with System Center, Operations Manager, and Unix and Linux, there are some things we need to set up on our Linux box before we discover it. We need to set up some sudo authorization. We need to make sure that our user accounts are configured, that we've got good name resolution going. So I've simply automated all of those configurations, the user creation, the home directory for that user, sudo configuration. I set an authorized key for my user, manage my resolve.conf. That's all scripted out in this SMA runbook, which is applied to the VM automatically. And if I jump back to my automation jobs, with any luck, that actually worked on our deployment from earlier in the session. Looking at script logs is like such an exciting demo. But in theory, oh, that failed. Looks like a name resolution problem. Yeah. I got reverse lookup. I did one earlier just in case. All right. So from the deployment I ran this morning, I actually apply that configuration. I also use SMA to deploy the Ops Manager agent, that DSC configuration deployed the CM agent. This is role demo 1 that should have shown up in Ops Manager. So Of course, we can keep reapplying that configuration. In fact, I have an SMA runbook that does that. We can also do that through a pull server. So if you're using PowerShell as an automation platform, definitely check out DSC for Linux. It's super useful. And again, if you're using Chef or Puppet, that same kind of approach of bootstrapping in VMM and integrating it there is definitely viable. So I do hope that we've conveyed the message to you that we're absolutely serious about this. Our team is growing. The feature areas we're working on are increasing. The pace at which we're doing Linux features is increasing. And we've been doing this for a while. We have a lot of machines in production environments managed with System Center today, Unix and Linux machines managed with System Center today. And this is something that you will see Microsoft as a company, investments in Linux continue to increase as you have over the past few months. All right, so I assume everyone has seen some of these slides. It's the first time I've seen it. All right. I encourage you to finish your evaluations. We have some time, so I'm happy to take questions. We will be hanging out here for a bit, too, if you want to ask a question directly to us in the product team. And then I think we'll probably be back at the booth for a bit the remainder of the afternoon. Any other questions before we step off the stage?
Yes, no.
All right.
No questions.
Well, thanks, everyone.
Yeah, thank you.